Hi everyone, good morning. Hi, good morning. Hi, in the last class we have discussing about the set theory and it is a totally 14 days gap we have before this class. Yes, I think you can hear my voice. All of you can hear my voice. So there was a gap of 14 days. Today we will continue the next part. That is the some parts we have to continue. So I hope all of you have the notebook and everything is ready. So just we will go through it. So in the next last class we have discussed. Okay, let us start now the class. Okay, let me start today's class. So one by one we will discuss. I think all of you can hear my voice. Yes, clearly. It's audible. All of you can hear my voice. If it is yes, you type as yes so that I can continue. Hi everyone. Yes, it is audible to you. My voice is audible. So how many of you are just to text me so that I can call? Yes, Prema is here, okay. Ananya Udupa is here. Then one more Harikantra, there's Ramachandra Harikantra it seems. Okay, welcome all of you. So let us start in what you have learned in a previous class. Let us start with the intro. Welcome to PSM for First Solution Math. I am your tutor Sumant here. In a previous class, we have learning about the sets. In the sets, we have already learned what are the things we have learned. Just we will go through it. So first we have learned about the simple definition of the sets. Then we will went for the note. That is how we will denote that. Okay, which alphabet we will use for denote which sets number system we have learned, and then we have gone through the several things, the elements, roster form, then set builder form, and lots of things. That the rule method we are going to call set builder form is also called the rule method, and roster form we have that we also we have learned. So these are the parts what we have learned so far, and also we have learned some of the parts, that is finite and infinite set. Okay, that is the thing, and what is belonging, what is not belonging, that is also we have learned, and we have converted the roster form to set builder form. Okay, now it is our today's class is the types of the sets. The types of set here what we have. So once all of you have to listen, the type of set what we have, it is most important. In your first PUC syllabus they have not mentioned all the types of sets, and according to that we have the lots of parts. Again, the types, we have lots of types. So I will discuss what is important for you. So there are last time we have discussed about the 8 parts. The first one is here, that is a finite set, then one infinite set, then the singleton set or unit set we are going to call, empty or null set we are going to call, joint or overlapping set we are going to call joint, disjoint set, equivalent and equal set. These are the 8 forms we can divide a set theory. But for your syllabus, for your PUC syllabus, the first PU syllabus, they have not given all these things. They have given some of this. This is finite, infinite they have given, and equal set they have given, and some of the other parts also they have given, only that much. Okay, but I will give a whole. Okay, hello everyone, Avana. So here importantly I am going to discuss all about this eight set types quickly. Okay, first we will move on to the finite set. There are 8 types. In that first one, the finite set. So what is the finite set? Anyone want to, if you know, you can say that, or I can explain to you. See, the finite set what we have, no? Actually a set which is having a finite number of elements. So already you know what is the element of a set. So if you are taking a set that is A, that is equals to, and there are some only few elements in the set A. For example, we have the 2, 4, 6, 8 and 10. If you have only these 5 elements here, if you will count it, you can find to one set, 1 element, 2 element, 3 element, 4 element and 5 element. So here we have only 5 numbers, that 5 elements in a set A. So that A set is called as what? Finite set. It is easy, it is not difficult. But some students will get confused because of the statement form question. That is the not this form, the rule form or what we are going to have. In that form some students will get confused. What is the confusion you may have over here? Okay, that confusion we are going to see now. So B is equals to, now I will take some elements, natural number. If I write natural number, whether the natural number is a finite set or infinite set. Infinite means the uncountable, means it is not endless, it is not having the end, it is continuous. So that numbers are called as sets are called as infinite set. So anyone, will you give that natural number is a finite or infinite set? Just to glance it quickly we will move. So it is already know that. Okay, so anyone you can say if you know already. So all the natural numbers, infinite or finite set. Yes, it is the B is equals to natural numbers. What we have now, actually this is the infinite set, because you can see if a B, if you are going to take the natural numbers starting from the 1, so 1, 2, 3, 4 and 5, and it will continue, it is not having the end, it is continuous, so it is called the infinite set. So set B is infinite. Yes, infinite set, because here we have, yes, very good. Infinite set means having the some elements, not all, finite number of elements. Infinite means there is countless, means we can't count them in. Okay, so that type of elements, if you have a set, is called infinite set. That is not difficult. So similarly, if we can take one more example, C is equals to X, such that X belongs to N. Okay, then I can take the X is greater or equals to 2 but lesser than or equals to 10. So whether this is C, set C is a finite set or infinite set? Set C is finite or infinite? Quickly, these are the question they will not give for your exam point of view, but these are the things you must remember. Okay, so this is a finite or infinite set? Yes, obviously it is a finite set because the starting from 2. So some students will say that, hi everyone, some students will think that it is greater than 2. Remember the x value is greater than 2. Means here the n natural number, x is a natural number, already they have given. So x such that x is belongs to n and x is greater or equals to 2 but lesser than or equals to 10 they have mentioned. So x value is equals to 2. They have not mentioned only 2 is like this way, they have not given. X is greater than 2 they have not mentioned, greater or equals to they have given. So this symbols lies that greater or equals to. Similarly here lesser or equals to 10. Means from 2 it will start, 2 next 3 4 5 6 7 8 9 and 10. So last number also we have to include because here we have lesser or equals to. So next, this is the number of what is the set we are going to have here, and here clearly we can count the elements 1 2 3 4 5 6 7 8 9 elements we have. So C is finite. Okay, so finite set we have. So similarly we can give infinite. Infinite means countless, that's all. So one more last question I will give you. D is equals to prime numbers. Whether now this D is a finite set or infinite set. Okay, you can write down all prime numbers or prime numbers it is enough, but all prime numbers I have written. So what is that D value refers to? Whether it is a finite or infinite? Yes, that time several students have given the answer correctly. Yes, all prime numbers we have, whether it is a finite set or infinite. Yes, definitely it is infinite. Very good, Ananya. So infinite, why it is infinite? The prime numbers they have given. Prime number starting from what? What is the prime number starting from? Whether the prime number is starting from 1 or whether it is starting from 2. Whether prime number start from 1 or prime number starts from 2. Prime number starts from 1 or 2. Hi everyone. Whether the prime number starts from 1 or 2. This is most important because some students don't know. Prime number, hi everyone. The prime number starts from not 1, prime number starts from 2. 1 is not a prime number. Remember, 1 is not a prime number. 2 is a prime number. First prime number is 2. Then we have 3. Then we have 5. Then we have 7. Then we don't have 9. Then we will have the 11. Then we have the 13 and so on. Remember, we don't have the end for the prime number. We don't have the end for the prime number. But remember, the prime number, it will not start from 1. Because the 1 is not a prime number. 1 is not a composite number. Because 1, what is the definition of the prime number? Any number divide by itself and 1. Okay, so if you will take 1, it will divide by 1, yes, and itself means 1 only. We can't take the same thing, means 2, minimum 2 division numbers we must have. So if you will take here 2, we can divide this by 2 also, and we can divide it by 1 also. Okay, but 1 will have the factor as 1 only. So it is not a prime number, whether it is not a composite number. So all the prime numbers start from the 2, and only one even number, even prime number is 2. Remember, only one even prime number is 2, and it doesn't have the end for this set D. So D is infinite set. This is the most important part, remember. So this is about the finite and infinite set, and you can have the understand. I think you can understand this finite and infinite set difference. So these are the two types of the sets what we have discussed. In your syllabus point of view, next we have to move on to equal sets. But here again, these are the set we have. These are sets, the types we have. What is this? All these different types. Just I will glance it. Singleton or unit set. You have know what is singleton or unit set. What is singleton or unit set? Singleton we will call singleton or unit set. Do you know what is that unit set or singleton set? This is the next part of the types of the sets. Just to understand, because this is important types. So sometime it may be asked. So for that purpose, you must know what is singleton or a unit set. So here name only suggests single. So and unit and single is nothing but only one. means a set which containing only one element, means at least one element, means minimum no, maximum one element you must have, minimum and maximum, not minimum also maximum also. The set must contain only one element. That element or that set is called a singleton set. For example, P, that is I can take that P is equals to 5. This is a singleton set, means it have only one element. So similarly, we have the Q, that is also we can take as a set, and it may contain only one element. So I will take as A. We can take numbers or alphabets or anything. So one more R, that is equals to, R is one more set, and that is equals to, yes, very good, Prema. R, that is equals to, we can take any one, that is N I can take. So these are the sets. Okay, the capital N I have written, no problem. Or I can take one more, last one I will take. S is equals to X, such that prime number between 10 and 12. So what are the prime numbers in between the 10 and 12? How many prime numbers you have between the 10 and 12? So whether this is a singleton set or unit set, how many prime numbers you have between 10 and 12? So again, it is a simple one. So x is equals to, see here, x such that prime number between 10 and 12. So here between 10 and 12 we have only one element, that is 11, and 11 is a prime number. Yes, very good. That is 11 is a prime number that is containing only one, and you can see the set is containing only one element. So this is called as what? Singleton set. Very good, Alia. Very good, Prem. So we have the singleton set. So next one we will move on to the next part, that is the next one. Singleton is over. So we have points, singleton unit set you understood. Next we will go for the empty or a null set. Empty or a null set. So this is also very important. Name we have two, but the meaning is simple. Empty and null. Empty and null is nothing but which is having zero elements, which doesn't have any element. A set which contain no element is called as a empty or a null set. For example, if you will take that A is equals to, and we will write the null set as like this way. The bracket will be open and closed, but inside that we will not write anything. Then it represents as a null set or a empty set. Empty means nothing. So next one more we can take that B is equals to, we will write like this way also. This is also symbolically as a null set or empty set. This is called as a pi. This is a symbol what we have here, that is called the pi. And if you will write like this way, it is a null set. It is denoted by the like this way. So empty set or null set is denoted by like this way, open and close bracket, or pi. Pi is null set. So for example, I will take one more example. C is equals to natural number between 1 and 2. So you can see between 1 and 2 any natural number you have. We have the fraction numbers, but whether we have the natural numbers. We have the fraction numbers in between 1 and 2. We have 1.1, 1.2, 1.3. Like that way we have lots of fraction value, 1.11, 1.01, 1.001. Like this we have lots of fraction value. But here the question is natural number. The name suggests natural number. So here C is equals to nothing we have, or this is also give written as pi. So it is called the empty set or null set. That is the next part you must remember, empty or a null set. Next, if you will move on to the next part, joint or overlapping set. So next part, I think you don't have any doubt in this. So these are simple one. Now little bit you have to remember joint or overlapping set. This is important. joint or overlapping. Okay, double P it is overlapping sets. This is important. Why I'm saying this important? Because from here onwards you are going to consider not only one set. From here onwards you are going to consider the two sets. So finite set, infinite set, singleton set and null set, what we have learned so far, we are considering only one set, that is A or B or C, D, like say only one set we are comparing. But coming to the joint set and further, we are comparing the more than one, that is 2 3 sets we are going to compare. So here you are going to have lots of things: joint, overlapping set, then we will have subset, proper subset, and all this will come now. So it's most important part from now. What is joint or overlapping set? So name only suggesting here joint or overlapping. So you can see if the two sets both of them are joint or overlapping set, then it must contain at least one element in common. At least one element in common means if you are taking here P is equals to 1, 2, 3 and 4. This is the one P set I have taken, and one more set I will take as a Q, and the Q is containing the elements. The same elements I can take, no problem, but I am taking little bit differently. The even number from 2 to 8 I am taking. So in this case, both the sets are called as a overlapping or a joint set, because here some of the elements are common. So some of the elements are overlapping. Which are the elements are overlapping? In both the set there is some elements are common, that is 2. Here also we have 2, and here we have 4, and here also we have 4. So this, if any element, at least one element is common in both the set, then the two sets are called as what? Overlapping or joint set. This is very important. Now we have to remember. So if you want, I will write down one small definition. You can write it down. If at least, yes, very good, Alia. If at least one element is common in two sets, then these sets are called joint or overlapping sets. So very easy it is, not a difficult. So at least one element must be common. So I will take at least one, means it may have more than one also. So I can take the 1, 3, 5 and 7, and one more element, that is S I will take, that I will take it as 1, 9, 17. Okay, this is a set I am taken, one more set I have taken. In this, one is common in both the set, therefore these two sets are joint or overlapping set. That's all. So I hope you have understood this overlapping set. So this is the set where the one element, at least one elements are common. Now we are going to have the next part, that is called a disjoint. So what is disjoint now? Name again saying that joint here and here disjoint. What is the disjoint? Suggesting disjoint. Disjoint means none of the elements are common. None of the elements are common. For example, I will take the A, that A is equals to 2, 4, 6, 8. And here I will take the B, and the B is equals to 1, 3, 5 and 7. So any elements are common in these two sets, that is A and B. Any elements are common? None of the elements are common. So these two sets are called disjoint. A and B, okay, set A and B are disjoint because no elements are common or overlapping. Overlapping means same. So this is called the disjoint. So I think you have no doubt in this joint and disjoint sets. So next part we will move little bit quicker. Now it is important, the last two types of sets we have, that is one is equivalent and next one is equal. So equivalent equivalent we will call. So what is that equivalent set? So equivalent set we have, and one more we have equal set. That is, both of them will get confused. So yes, in a previous class I have discussed about this. So what is equivalent, what is not equivalent, we have discussed. Just we have given the introduction for you. So anyone those who know about the equivalent and equal sets, you can answer. Both looks like a similar, but both of them are not similar. Both of them are little bit different we have. Equivalent set, and one more set I will write on equal set. So here you can see both the things. Equivalent means the cardinal points, the cardinal number of a set must be equal. Cardinal number means, cardinal numbers in a previous class we have discussed. That is, the cardinal number is nothing but how many elements are there in a set. That is called the cardinal number of that set. For example, if I have taken here m, okay, that m when we will take, and here we have that 2, 4, 6, 8, 10 and 12. This is the set m which containing the element. What is the cardinal number of this set? Anyone will you answer? What is the cardinal number of this set? 2, 4, 6, 8, 10. So what is the cardinal number of this set? 2, 4, 6, 8, 10 and 12. Anyone? If you are online, you can answer to me. No problem. So here the cardinal number is how much? That is n of m. I have to take n of m. N of m is equals to how many elements are there? That is called the cardinal number. So 1, 2, 3, 4, 5, 6 numbers we have. So n of m is equal to 6. Very good. That is Ananya. So n of m is equal to 6. The cardinal numbers are 6 here. Similarly, we will have one more. Yes, we have one more. Very good, Ananya. So one more we have n. That is equals to. We will take one more number, 1, 3, 5, 7. Oh, sorry, 1. Okay, 6. Let it be, no problem. Then we will take 8 and 10. Here I am not finding which are the elements are common. I am not going to find here which are the elements are common. So some of the elements may be common. Here you can see 6 is there. Here are 6 we have. 8 we have. Here also 8 we have. Here we have 10 we have. Here also we have 10. That is not the problem. Here equivalent set means the cardinal numbers must be same. So how many elements are there in n? 1, 2, 3, 4, 5, 6. So here n of n is equals to 6. So equivalent set is nothing but if the cardinal numbers are equals to one another. If the cardinal numbers are equals to one another, then we will call that set m and set n are equivalent set. Set m and set n are equivalent. Yes. Okay, this is about the equivalent set. Now let us move with the equal set. What is that equal set refers to? Same rule. So we will take the example, that is I will take the p, that is equals to, I can take it as any number. So I'm going to take here number sum. Okay, 1, 2, 3, 4, 5 and 6 and 7. So these are the numbers I have taken as a p. Here we are not supposed to see cardinal number. Here it is not the thing to take the cardinal numbers. Here we have to take one more set, that is q, and that q must contain the same elements. Remember, the q must contain the same elements. Means what the p set we have, similar elements we must have in a q elements, q set. That is, if we have here 1, here also 1, here 2 means here also 2. And remember, it must contain all the elements. Not a single number have to be different in both the set. If here we have 6 and here we have 6, and suppose here we have 7 on the p but we don't have a 7 on the q, then these are not called as a equal set. These are not equal set. It is not equal. Okay, we must have same number of element and same elements in both the sets. So now you can see both the elements, that is both the sets containing the same elements. So set p and set q are equal sets. Equal sets. Okay, so these are called equal. Difference is simple. Equivalent means the cardinal number must be same. Equal set means the elements of the both the sets must be same. That's all. Here we can have different elements. In an equivalent set we can have the different element, and it may be anything value. So I can take any value. Okay, so this is both the sets are equivalent because cardinal points are same, that is 6 and 6 here. But in this case all the elements must be same. So I hope you have understood difference between the equal and equivalent set. Okay, so this is the end of the types of sets. Okay, again we don't have any types of sets leaving this. So totally 8 types I have discussed today, and next we will move on to the next part, that is called as a subsets. This is not the type. Remember, subset is not a type of a set. So some students will get confused. Name the types of the sets they will ask, means you will write down all: finite, infinite, equal set, joint set, disjoint set, singleton. Okay, lots of things, equivalent, equal, everything you will write, and also you will write subset. Whether the subset is a type of a set. One question: whether the subset what we are going to discuss now, whether it is a part of a set. It is a part of a set. Whether it is a type of a set. It is not the type of a set. It is a part of a set. Remember difference you have. What is the part and what is the type? Type means there are different types of a set number, but subset is a part of a set. For example, if you want to have the subset, no, actually we need one universal set. Okay, we must have, yes, very good. We must have a universal set. Here the name called as a universal. Okay, there is a name as a universal. What is that universal set? We will have universal. Again we have parts. Okay, in set theory again we have parts that I have not mentioned in your notes, so I will not make any confusion for you. If I want to say, no, there will be lots of parts we have. For example, simply I will write it down just to make a note of it, and when you are fine having the time, no, just you make it. So subset we have, then we will have universal set, then we will have proper subset. This one you have proper subset you have for your portion, proper subset. Then you will have one more called as a superset that you don't have for your syllabus. Superset we have that you don't have for your syllabus. Then universal set we have already gone through it, and one more complement of sets. I think you have the complement of sets. Okay, these are the union of set, intersection of sets, all these things you have. We will discuss the simple one first, that is the subset. If you want to know what is subset, you must need the universal set. Okay, one universal set we need. So universal set means what? Universe means everything. So universal set we will note down as u. Remember, we will note down as u, or also it is given by one more alphabet that is called as xi. One more alphabet that is called as xi. So it is pronounced as xi, but pxi. Okay, that is the name given as pxi. Universal set given by two, denoted by two things, that is u, and one more is xi. The p is silent, so pxi, xi. Okay, so the universal set is nothing but one set which is containing all the elements. For example, if you have a u, that is equal to universal set, always we will write down as a u, okay, or xi, but most of the numbers of the case we are going for the u. U is equals to, I will take all the natural numbers. So natural numbers means you can understand it containing from 1 to infinite. So that u I can take it as 1, 2, 3, 4 and so on, because we don't know the last value. So this is called as a universal set. For example, now I have taken. Now what is a subset? In this universal set, we have to take some elements. We are not supposed to write all the elements. We have to take some elements, that is some elements what we are going to take from this u, that is called a subset of that u. For example, we can take the a is equals to 1, 3, 5, 7, 9. Okay, this much element I have taken from the U. So A will become the subset of that U. Okay, so I can write it down that A is a subset. How to denote that subset? Subset is nothing but like this, subset of U. Okay, and you may ask whether we have to take that U only. No, you can take it different also. I am talking about the universal set. You are taking that some parts. In subset, we can take one set as a big set. That is the I can take as a Q. I will write down some numbers here. That is A, B, C, D, E, F, G, and H. It's enough. Now I will take one more element, that is one more set I will take, that is I will take the P. That P set is containing A, E. Okay. So A, only two elements I have taken. From where I have taken this A? I have taken this A from this set Q, and I have taken this E from the set Q. So now I can say that P is a subset of Q. Understood? P is a subset of Q, means I have taken this set P from where? The elements of this set P I have taken, this A and D I have taken from where? That is I have taken from the Q. Means P will be a subset of Q. Yes, very good, Prema. So this is the most important thing. So next, similarly, you have understood what is universal set now. Universal set is nothing but it containing all the things. So here I can take this Q as a universal set. I can take that Q as a universal set, and Q is also called as a superset also, remember. Q is also called as a superset also sometime. So don't get confused what is universal set and what is superset. So from which set we are taking the element, that set is called as a superset. Means here we have taken this A and E, that P set, we have taken the elements of the P set from the Q. So this Q is called a superset or universal set. Okay. So let us take one more example. Here little bit confusion you may have, because I want to see how much you have understood. So now all of you remember, I will take one more element, that is M now. That M is equals to set I will take, and I will write down 1, 2, 3, 4 and 5. Okay, M I have taken, that is 1, 2, 3, 4, 5, and N I have taken as 1, 2, 3, 4 and 5. Whether I can write it down, N is a subset of M, whether N is a subset of M, I can write it down like this way, or I can't write down like this way. I am asking M is equals to 1, 2, 3, 4, 5 and N is equals to 1, 2, 3, 4, 5. So whether I can write it down that N is a subset of M, or I can't take that N is equals to subset of M. Yes, very good, Prema. Here we can take that N is a subset of M. Why we can take that N is a subset of M? Here simple thing is, we have already given a definition. Elements of N, what we are writing, it must be part of the one more set. So here that 1 what we have taken here, this 1 is taken from the M, 2 is also taken from the M, 3 is also taken from the M, 4 is also taken from the M, 5 is also taken from the M only. And one more interesting thing over here is, both the set is equal set, because the same element it contains. The M set is having which element? That is N set is also having the same elements. Okay, very good. So here we can say that N set is also is equals to M, means equal set and also subset. Okay, so when we'll have that equal set and a subset, so this is the called as a subset. What is the difference between this set, that's an M and N, and what is the difference between this P and Q? Difference you can find. What is the difference between this first one example and second one example? If you will see it clearly, there is a difference between these two sets. So don't see about the universal set now. Just to glance on this above one and down one. What is the difference? The first one we have here and second one we have here. What's the difference? Don't say about the universal set. So here only I can say that one is subset called a subset, and second one is also a subset, but it is given as proper subset. So which one is a subset and which one is a proper subset in this two? Whether the first one or second one is a every element must be there in both set. Yes, every element must be there in both set. That is called as a subset. Means the second one what we have here. This is the second one what we have. This is called as a subset. This is a subset. Remember, it is not the proper subset. It is only a subset. Subset it is. Proper subset is this one. This one is called as a proper subset. Remember, proper subset is nothing but there must be one element must not be present in the second set as compared to the first set. So here we have AE. So if I had instead of AE, instead of this AE, if I have A, okay, here I will take some more elements A, B, C, D, E, F, G and H. If we have like this way elements, if we had like this way elements, then it will not become the proper subset. It won't be a proper subset because here you can see that all the elements of set P is present in set Q. At least one element must be absent. Means I might have not written here H. So that what will happen? You can see A is present, B is present in the both the set, C is also present in the next set, D is also present in this set, E is also present in this, F is also over here, and G is also over here. So only one element is missing, that is H. So here I can say that P is subset of Q, that is proper subset. So it is a proper subset. Why? Because one element, at least one element must not present in the second set. Okay, this is called a proper subset. And second one what we have discussed, here all the elements are equal. So here you can see the n is subset of M, like this way we have taken, and next one we can write it down. Both of them are what? Both of them are equal also. See, I will write once again. N is a subset of M, and one more thing I can write it down, N is equals to M because all the elements are equal. So this is the subset. This is not the proper subset, it is a subset, and this can be rewritten as N is a subset or equals to M. Like this way also we can write it down. We get N is a subset or equals to M. So it is called as a subset, not proper subset. But the first one we will call it as subset also, proper subset also. But we will not make a big difference on the subset and the proper subset. Therefore, you remember, if you will tell that first one is P is subset of Q, what I have given, no? Then also it is correct. If you will say that P is a proper subset of Q, then also it is correct. Then also it is correct. Because the proper subset concept we will not use in day-to-day life and anywhere. We will not use the proper subset. So one question I will give you, just to write it down and say to me whether it is a proper subset or not a proper set. M is equals to, I will write down, that is 2, 4, 6, 8, 10, 12, 14 and 16. And I will take one more element, that is N, that is equals to 2, 4, 6, 8, 10, 12, and I will take one more O, that is equals to 1, 2, 3, 4, 5, and I will take one more P, that is equals to 2, 4, 6, 8, 10, 12, 14 and 16. Okay, I've written. So now which is the set here is a proper subset and which is the set is a improper subset, and one more we have that is a little bit different. What it is? So answer to me. So whether the I can write it down as a subset of M. Whether I can write down the N is a subset of M. Whether it is possible to write. Whether it is possible to write N is a subset of M. Actually, we can write down that n is a subset of M, because here 2 we have 4, 6, 8, 10 and 12. It present in the first set. So M is a universal set. So we can write down n is a subset of M. Yes, we can write it down. N is a subset of M, or n is a subset of M also we can say, or n is proper subset of M. Both the definition is possible. Both the definition is possible. But coming to the second one, O is equals to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 we have. So here you can see none of the elements, some elements are equal. That is 2 is there. Here also we have 2. Here we have 4. There is also presence of the 4. But other elements, that is we don't have 1, we don't have 3 and 5 in this M. So it is not possible to say it is a subset or not subset. So O is not an a subset of M. So here O will not become the subset of M. And coming to the P, and the P is also, we can see all the elements of 2, 4, 6, 8, 10, 12, 14, 16 and 2, 4, 6, 12, 14, 16. What you have, all the elements are present. So P is a subset of M, only subset, not proper. It is only subset. P is subset. Yes, very good. That is Prema Naik and Alia also you are given it correctly. Subset of M. And also remember, also it is showing that, okay, I will write down not only subset, P is not only the subset of M, P is also, not C, it is subset, okay. P is also equals to M, so both we can write down like this symbolically, means subset symbol is this one. P is subset of M, M is a subset of P. Yes, very good Prema, that also we can write it down. P is a subset of M also we can write, or M is subset of P also we can write, because of the same elements presence. Okay, so this is all about the important topic, that is subset, universal set, and we have discussed. Universal set is nothing but every elements it will contain. So every element. So I hope you have understood this. You don't have any doubt regarding this. But when it will come the subset, one most important thing you must remember, note. See, all the natural number I already know that what is the natural number and all, whole number, natural number, integer. So integer is a total. Integer is a total. In integer we have a parts. So integer means what? There is a positive and negative number, including 0 we will have. So in integer the center is 0, means the positive 1, positive 2, positive 3, and it will move on towards the right hand side. And similarly negative 1, negative 2, negative 3, and it will move towards the left hand side. And very importantly, integer we can write it down the whole number. In integer there will be whole number starting from the 0 towards the right hand side. And next, in whole number we can have the natural number. Remember, there is a part. Yes, natural number. So there are some parts. This one you have to remember. Why I am giving these definitions for you, that why I have written this, because integer is a whole. Integer is a whole part. Okay, that is, if you will take, this is a round circle, if you will take, this is the integer, if you will consider, in that we have the whole number. Remember this blue color what I have written, think that this is a whole number. Okay, inside that again we will have the natural number. Okay, so always you remember one thing, clarification I will give you. Natural number denoted by n, whole number is given by w, and integers is given by z. Okay, so natural number is n, whole number is w, and integer is z. So natural number is always a proper subset of okay, I will take this pink color, it will be good. So natural number is always a proper subset of whole number. because it include all the elements of the whole number. Okay, then also it will continue. Whole number is a proper subset of integer. This symbolically you must, if you remember, you can answer any of the question, because the natural number start from 1, 2, 3 and so on. It is including a whole number, that is 0, 1, 2, 3 and so on. It is including in the subset of the integer, that is nothing but -3, -2, -1, 0, 1, 2, 3, so on. So you can see here clearly the first one is the natural number, second one is the whole number, and the third one is the integer, and all these are subset. N is a subset of W, W is a subset of Z. So we can conclude one thing. So natural number is a subset of W, and also the natural number is a subset of Z. Next we can write it down, W is a subset of Z. This is the conclusion we can give. So this much you have to remember today. And what I have drawn here, no, this is called the Venn diagram. That is, I have drawn a circle and all. No, this is called as the Venn diagram that we will discuss in the next class. Venn diagram, and also we will learn about the operations of set theory, that is union and intersection. You have already learned this. I know in your school, college, they have already taught you, but we will discuss this union and intersection, and one more we have complement of sets. So this one, three things we will learn. And De Morgan's law, you have the De Morgan's law is very important for your examination point of view. So see you in the next class. So today it's enough. Thank you for watching PSM. So like, subscribe and share. Tell your friends to join in the next class. It will be good for them also. So see you. Take care. Okay, Prema, I will conduct the class on the relation from function in the next means after finishing one more period I want for the set theory. Within next period I will complete the set theory. It is not the big lessons we have, a very small lesson we have. So let us complete this set theory. Then we will move. I need another 2 classes to complete this. So we will see if it is possible in not Sundays and any other day also I may take the class, if you are free, all of you, means in the evening time. Then I will move on to directly your functions, relations and functions. Okay, take care, all of you. Okay, give much more importance to the graph. Okay, which graph you want? Which graph? Okay, Alia Patan. Okay, which graph you are talking about, Prema? I'm not getting it. Venn diagram you are talking about, or functions and relations and functions we are talking about? So if you have any doubt, you can go to my Instagram. There also you can text, or WhatsApp number you have there also you can text me, or you can, if you don't have my numbers, you can go to the social media link also, no problem. Thank you, Ananda.